We finished with the quantitative, what's the code? Let me pull it up again. LEP something. Thank you. Did you get it? Lepze.
I don't know.
Good? Okay, thank you. And you got your lifting coordinator there too. All right. Important stuff, right? All right, we are going to go back and actually do some of the quantitative graphical displays on your calculator so I can show you where that comes from and how you go about creating those. We're going to start talking about the categorical first. So you'll need your calculator eventually, but not immediately. Okay. So I have one really, like I have some of the really old kind of calculators. They're less enjoyable to use because they're much less intuitive.
Yeah.
So I would say, do you have one at home? Okay. I would just work with your neighbor and like watch as you're putting stuff in, or just jot down the keystrokes if you need to. We're gonna do them multiple times in class, so it's not the end of the world if we don't have it today. Okay. All right, guys. But first, we'll talk categorical data. So the first one we're looking at here is a bar graph. It looks a lot like a histogram, but it is a little bit different. You actually have spaces in between your bars. Okay, so different than a histogram. If you're creating a bar graph, you'll always want to leave space between the bars. This is for categorical variables, and so you're always going to find your categories on the x-axis. And you'll usually see percent over here on the right. You can do it with like counts in that category, but when we start talking about analyzing these variables, you're always looking at proportions, and so you're going to want percents when you're doing your bar graphs. And then it's similar in a pie chart. You guys have seen pie charts since you were in elementary school. But again, you're looking at the percentage breakdown. And each little slice of your pie is going to be one of your categories there. Okay. And then we have our segmented bar. Again, percentage that we're looking at here. Oh, sure. Always. Yeah, did I go too fast? Sorry. You good? Okay. I tend to write quickly, so just tell me if I go too fast or anything. And again, when you're looking at a segmented bar, sometimes this is used sort of when you have multiple categories kind of within categories. You can see how it's broken down. Each of these below basic, basic, intermediate, and proficient, they're going to have 100% total. And then within those, you've got like 3 other categories, and you can see the percents of those based on the segments within your bar graph. Okay. It's just different ways to organize your data so that you can analyze it or put it in a visual form that's useful to you. And you'll have to create a few graphical displays for me, but it's not like we're going to spend days where you're just drawing multiple pie charts and bar graphs and things like that over and over, okay? It's more, can you read the information that's given to you? And this one's different. This is called a mosaic. It's just kind of nice for making comparisons. Like, you can look at just, let's say, the American category here, and you could say, okay, they make the most medium-sized, I think we're talking about cars here. But then you can make a different comparison from country to country, because you can see that, you know, small cars in Japan is a much bigger chunk of the whole little mosaic graph here than anything else is. So does that make sense? You can kind of read it in the vertical columns, and you can make comparisons. Yeah.
So is the size like a little bit like more like population comparison in America versus here?
It's like kind of like a count comparison. So like, even though you could look here within the American, like the blue up here, the small, like that's the smallest percentage for the Americans, but that's still more total cars created than the Europeans, because you can tell if you compare those 2 boxes, like the size of them matters. It's kind of a weird distribution. So it's sort of vertical comparisons and overall comparisons. That's not one you see very commonly on an AP question, okay? All right. So the next part here, like going through those was pretty quick. The next part is the most important part of Unit 1, and it's something you're going to do, like you're going to see repeated later, is being able to describe a distribution. So we talk about cuss. You're going to have to cuss about your distribution. It stands for center, unusual features, shape, and spread. So, super important. You always want to hit on all 4 of those things when you're describing a distribution, okay? And there's multiple ways you can describe these features on a graph. So the first one, your center. You could talk about the mean, which you guys know is just the average. We can also find a weighted mean, and I'll walk you through an example here with that. The median is another way you can describe the center, as is the mode. A lot of times, median is the only one you can see if you're given your information just in a graphical display. So there's no like, oh, this is the way you have to describe the center. It's based on the problem, based on the information you're given, which of these is the easiest to describe, which one makes the most sense. Sometimes you can use multiple, that's fine. But you just have to describe the center. So weighted mean, you guys are used to just finding the average, right? So weighted mean you're a little bit used to this because of how your grades are frequently calculated. So if we look at this one, you get an 83 on your midterm and a 95 on your final. Not that you guys ever deal with midterms and finals anymore, but still. And 40% of your grade is your midterm and 60% of your grade is your final. That could be what you have in college. You'll have a class where you have 2 grades, the midterm and final, and that's it. So weighted average here, all you would do is take the 40%, so 0.4 times that midterm score, which was 83, plus 60%, so 0.6, times, what was it, 95? And then here, we're dividing just by 1, because what you're dividing by, what this messy looking formula has here, that's the sum of the weights. Okay, the sigma means sum. 0.4, 0.6, that's 1, okay? So you don't have to show that. That's what's happening with your weighted mean. So what do you get if you calculate that weighted mean, guys? Perfect. You get 90.2. So what do you think? Are you going to get an A? Yes. You get an A. Okay, so that's just the difference between a mean and a weighted mean. You've got different weights for your different scores that you have going on there, okay? Do you guys know what the median is? Like, do you remember from earlier math classes? Yeah, what do you think, Joe?
Middle number?
The middle number. Is it, no matter how the numbers are listed, is it the middle number?
It's the middle number, like, from smallest number to the biggest number.
Okay. Yeah, so middle number in an ordered list is what I would say. And then what's the mode? Yeah. Yep. I'll say most frequent, but most repeated. Yep. All right, and then what I've written down below that, when you add a value considered an outlier, so something that's far away from the rest of your values, the mean is going to be more impacted than the value of the median. So the mean is less resistant to outliers. Like, this whole little paragraph is pretty important to understand, and I'll draw it out for you with some numbers here. But understanding the difference between mean and median and how those get impacted by either adding another value or taking a value away. So let's say we had, we'll just do some simple numbers here. 2, 4, 6, 8, 10. Super complicated set of values there, right? So our original data values here. And actually, let's make it, I'm changing it, 2, 4, 6, 6, 10. Just to really get my point across. All right, guys, what's the mean and the median for this set of points? And it's okay if you want to use your calculator to find the mean, that's fine. Yeah, what do you got, Luke?
86.
Good job. You got the mean? 5.6, is she right, guys? Yeah, okay, I knew it was 5 point, I didn't do the rest of it. Okay, so that's fine, right? Let's say I now put an outlier in here. So I've got 2, 4, 6, 6, 10, and 52. What's my new mean and median? Yeah.
The median is still 6.
The median is still 6. Look at that. What's my new mean? 13.3? I'm trusting you. I don't know, guys, I'm sure. Okay, so I added this clear outlier, right? Like it's different from all the rest of the values. It did nothing to the median. Okay, didn't change it at all. Definitely impacted your mean. So the mean is not resistant to outliers. Okay, so sometimes it makes more sense to use the median when you're describing the center for your data values because it's not going to be impacted by things that are, you know, out of the norm, that don't really follow the rest of the data. Okay, does that make sense? All right, let's turn the page. Okay, so that was describing your center. I know I'm not going in the order CUSS here, but we'll do spread next. So spread is talking about how much your data values vary from each other, okay? Oh, can you keep your mouse? Thank you. So there's a couple of ways we can look at that. We can talk about variance or standard deviation. Those two go together because remember standard deviation is just the square root of variance. Now I've got all these formulas for you on here. You're not going to have to calculate this by hand. Okay, your calculator is either going to do it for you or the problem's going to tell you what the standard deviation or the variance was. So yes, these formulas exist. I even have, like, we have this example in here. I'm not going to make you do this by hand. Okay, I'll show you on your calculator how you do it. This over here, remember this is from your population. These are the parameters. We'll review that again just because it's important. And this is all from the sample. Those are called your statistics. Want that to be automatic so that if I say, oh, what's your parameter? You know I'm talking about something from your population. And these with the squared values, those are variance. And just the sigma or the S, that's the standard deviation. We talked about those last time, but I know those aren't ingrained in your head just yet. And then as far as in the formulas, the SS, those are not new variables. Like, I'm fine with just crossing these out. What the SS stands for is the sum of the squares, which is essentially what all of this means, but I think it looks like more variables. So if you want, just ignore that part on all of them. Again, you're not going to do any of this by hand, so it's not a big deal. All right, so we're going to walk through how you would do this on your calculator. So first, we've got 4 friends at wing night, and they eat their wings, okay? I'm asking you first for the typical amount of wings eaten by a member of the group. Typical just means average, so we're looking at mean here. So I'm going to pull over my calculator and show you how you can go about doing this. With 4 numbers, you can easily find the average, but let me show you. how you can do it for anything. So, have your calculator, go ahead and get that out. All right, so we are going to make a list of our values first, and then we can calculate all sorts of things from that list. We can find the average, we can find the standard deviation, we can find our 5-number summary, all of that just from putting one list in our calculator. So we're going to go to Stat. Now, if you don't have a TI-84 Plus, or, you know, if every once in a while I get someone with a Casio and it's just different. So hopefully, looks like most of us have TIs, okay. If you're like, I don't know where this is, raise your hand. I'll get to you in a minute, okay? We're going to edit, which just means we're going to put values in a list, okay? So everybody should be at L1, where we can type in some values. So we're going to type in those 4 numbers, 27, 23, um, 29, and 21. Anybody stuck on like, I don't know where the list is? It's okay. Okay, all right. Chat with your neighbor too. If you get lost on something, let me know, or ask them for help. It's okay. Okay, once you have your 4 numbers in, we're going to go back to Stat. So I'm pushing that Stat button again. This time I'm going to calculate something though. So I'm going to arrow over to Calc. And we're going to pick that first one bar stats. That's one variable statistics. So push Enter or 1. Okay, I'll walk around, make sure everybody's in the spot. Yeah, it works really well. Yeah, it's good. Okay, so if you want to follow along, you can do whatever desk you can follow along with Josh, follow along with me, and you can review it in class too, but it's going to be, he's not going to cooperate well, okay? Okay, guys, so our list, mine was in list 1. I think most of you guys had it in list 1. There will be times when we have a frequency list. We don't yet, okay? So we don't need to worry about frequency list. That should be blank. And then just arrow down to calculate, push Enter. And hopefully this is what you see. Yeah, we're there. Okay, so nice. So what is X bar? What, I heard someone say. Yeah, what do you think? But what does X bar represent? Like, yes, it is 25. It's a statistics. It's the mean. Yes, it's the average of our sample. Okay. I know you guys aren't used to these symbols, so we got to keep reviewing those. So X bar, that's just your mean. That's the average we're talking about. We've got this sigma X our summation going on. Because this is a sample, we want to use the S sub x, the 3.6514, whatever. That is our sample standard deviation. Okay, so this guy is the one we would want to use. So that's standard deviation, this one. And again, does that make sense why I'm picking that one and not the one with the actual sigma in it? If it was sigma, what would it be telling me the standard deviation of? The population, yeah. And we just have a sample of 4 people. So we're using the S sub x for our standard deviation. And again, we have the mean. The other information in here that's really useful is if you arrow, oh, mine's not cooperating now. Maybe. Oh, there it is. Okay. You get the min, yes.
How did it like calculate the standard deviation of the population?
It's not accurate, it's just estimating it based off of what your sample was, so that's why we use the other one.
What place value do you want us to round to?
So different than calculus. 2 decimals, that's fine. Like I would say the standard deviation is about 3.65. If you give me 3 places, great. If you give me 1, great. Like, it's okay. It's very weird to be like, it's fine as long as you're close. But then this right here, this min, Q1, median, Q3, max. So that's giving you your 5-number summary. You could create your box and whisker plot from this. It also clearly shows you what your median is, which is nice. So this one variable statistics, you're going to use this all the time to get a bunch of different information. Okay? All right, so back to our notes. We'll go back and forth here a little bit. So we found the mean, or the average of our group here, to be 25. And then what this little paragraph is saying is not everybody in the group actually eats 25 wings. In fact, no one in the group eats 25 wings, okay? Everybody varies somewhat from this average of 25. And that's what the standard deviation is actually calculating for you, is how much does each person vary from that mean, okay? And we did it on our calculator, the standard deviation. Remember, it was the S sub x on calculator was equal to 3.65. So that's why standard deviation is used to describe the spread, because it's talking about how much those values vary from the mean. And we're going to jot down standard deviation. It's the typical distance, so we'll quote typical, from the mean. So that's what you need to understand with standard deviation. Another way you can think about it, if you have a really small standard deviation, that means there's very little variation in your data points, that they're all really close to the mean, above or below. If you have a really large standard deviation, that's, your points are all over the place as far as distance from the mean, okay? So that's what it's telling you. Other options for describing spread, we can also use the range, which that's just maximum minus minimum. So for our example with the wings here, that would just be 29 minus 21 for a range of 8. And then the third thing you could talk about is your interquartile range. Anybody know what IQR is? Do you remember? Yeah, go ahead. Exactly, yep. So when we talked about the box and whisker plots. It's basically the edges of your box, the Q3 minus the Q1. So look back at the calculator where we just had those one variable stats. What was your Q3 and what was your Q1? Yeah.
Q3 was 28, Q1 was 22.
Perfect. So 28 minus 22. Your IQR was 6. So none of this is like, ooh, that's super hard math, okay? I mean, we're just subtracting two numbers. It's really just being able to understand when to use which values and what they're telling you. All right, questions on spread. Okay, your calculator is your friend for that one, for sure. Okay, shape. We're talking about the shape of your distribution. So we drew some histograms last time. We had a couple of those. You could get shape from that. You could get it from a dot plot. You can get it from a box plot. You can turn all of those things into something you can describe the shape of. So first, what symmetric means. Draw a couple for you. And bear with me on my drawing skills, okay? So that is a symmetric distribution. If we're doing a histogram, that's symmetric. If it's symmetric, the mean will equal the median. Now, it doesn't have to be exactly equal to it, but if they're really close, you know you probably have a symmetric distribution. All right, another type of distribution is uniform. It just means it's the same the entire way across. So with, you usually see it with a histogram. It's just like everybody just lines up. That's uniform. It's technically also symmetric, but it's like a special type, like it's a more unique situation than symmetric is, so you want to describe that as uniform. Most of your data sets are going, oh yeah, go ahead, Kevin.
About the mean and mode all the same.
Yes, your mode would be potentially, depends on exactly what your histogram categories, like your groups are there, but potentially yes, they could all be equal. You might have more than one mode, because you could have several with the same count. So, yeah.
When something is uniform, would you say there's no range, or would it be 0?
So you have a range here, because like this, let me draw it bigger, just so you can see. Let's say we're talking ages of something, and this one is people ages 0 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. The range is still potentially 60, right? Because it'd be 60 minus 0. Does that make sense?
Yeah.
It's just bringing up mode. You have the same count in each of these groups, is what's happening there. Okay?
Yeah.
So it's kind of weird. You don't see uniform very often. You see a lot of skewed data, and that's what we'll talk about next. Skew right we'll do first. It's called a positive skew. I always just call it skew right. Let me draw it for you. That is not a great drawing. Let's try again. We'll do a histogram of it too. Easier to see in the histogram I drew there. The tail to the right, like goes to the right. So it's sort of clustered together on the left. That's where you have a bunch of data values, and then they're getting further and further spread out as you go to the right. And then a good tidbit to remember with your skewed data, the mean is going to follow that tail. So like your median might be, you know, near the middle here. Median right in there. The mean is always going to be greater than the median because it's going to get pulled by those more extreme values out to the right. Okay. The mean is less resistant to outliers. When you're done with that one, guys, go ahead, turn the page, and we'll do skew left. Go ahead and try and draw what you think skew left looks like. And I gave you way less space here, so sorry. So guys, wherever the tail is, that's the kind of skew we're talking about. The tail is like the little skinny part of your graph. The tail's to the left, you have skew left data. And this time your mean is less than the median. Okay, it's going to get pulled down. Again, your median might be near the middle here. And your mean is going to be over to the left. Okay, the other sort of shape of your distribution you could have is what's called bimodal or even multimodal. It's talking about your mode, that you've got multiple or two or more modes happening. So it's like you have multiple peaks happening in your graph. So I'll just do the histogram version. beautiful peaks. Mhm. So if they're right next to each other in the middle, you're not going to call it bimodal at that point. You're probably just going to stick with symmetric if if it follows the rest of the shape there. You need it to be too clear, like peak, come down, peak, and come back down. Okay. And when we look at these, we're usually using real world data. Real world data is not very pretty. It's not going to be this perfectly beautiful bimodal shape where it's even on both sides, exactly how you think it should look. It's a little off. You're like, yeah, I think I see two peaks in there. And if you describe that and can explain, like, hey, I saw a peak at between 20 and 30, and I saw another peak from 70 to 80, you're okay. Like, that's fine. As long as you're describing what you see, you can explain it. And if you're like, well, I didn't think those were extreme peaks, I described it as, symmetric or whatever it is. As long as you can support it, and you're not completely off. Like, if you saw this and called it uniform, I'm not going to give you credit for that, okay? But there are times when it's like, yeah, I could see describing that maybe in two different ways, just because it's not perfect, because it's real stuff, okay? So we always draw fairly happy examples of it, but that's not always what it looks like, okay? All right, finally, on to the U part, the unusual features. So outliers are a common unusual feature. So this is a values, or they are values that are extremely different. Yes. Good. It's going to give you that tail. And we do have formulas for defining what is an outlier. So Q1 minus 1.5 times the IQR, or Q3 plus 1.5 times the IQR. So guys, those are your boundaries. Like the Q1 minus 1.5 IQR, that's like the low boundary. Makes sense, we're subtracting, it'd be on the low end. And then this is the upper boundary. So if you calculate these and you have some number in your data set that's either lower than the low boundary or higher than the upper boundary, that's an outlier, okay? So you've got these like defined barriers. A gap is exactly what a gap sounds like it is. There's just a gap with no data values. So no data points. That one you would see most commonly in a histogram. Like you might have, you've got your little groups here, and then maybe you have nothing. You'd want to make sure and note, like, hey, I have a gap here between this value and this value. You move that up for you guys, sorry. Yeah. So let's say, like here, let's pretend so there's my histogram. When you're describing this distribution, you'd go unusual features and you'd say there are no data values between 20 and 30, or whatever your category is, or if we're talking age here, 20 years and 30-year-olds. So this would only come up when I'm saying describe the distribution, and you have to go through center, unusual features, spread, and shape.
What if there's like two, like next to each other? Like just two open spaces?
So like say this is in here too.
Yeah.
Then you'd say there's no data values between 20 and 40.
Okay, so it's
Yeah.
still in the unusual.
It is still unusual. Anytime you've got a gap in your points, you want to make sure you note that. And depending on how you're given the data, sometimes you can see it and sometimes you can't. Good questions, guys. All right, and then we have clusters. So the more formal definition of this, value or range of values with a noticeably large proportion of data points. So they're all clustered together, is what this is telling you. Now, it's not drastically different than I had a peak on my histogram. Like, that might also be a cluster. So it's, when you get into the problem, you'll see, like, oh, this is one where I need to describe that. This just falls into that.
If you have like a pie chart and one thing like 70%, would that be like a cluster?
So you're only going to do this with quantitative. So you don't have to worry about how to pie chart. Okay? Good question, though. All right. Let's see. We're going to do an outlier example, but I think I want to practice some describing first. So go ahead and turn the page to the practice exercises on the back. We'll come back and talk about how to define an outlier, like actually do one, but let's just practice some of the describing first, okay? Ethan?
I was just gonna ask, when you have this discovery, like how will this work? Say
Yeah, so it depends on what you're given. Like if you're only given the median, definitely only talk about the median when you do your description. If you have the mean, the median, and the mode, as long as you pick at least one of those to talk about and talk about it correctly, you'll be fine. Okay? All right, so first one here. Describe the distribution of incomes earned by people with advanced degrees from a box plot earlier in the notes. So first, let's go back and show you which box plot we're looking at. This one. Okay, so it is asking you to describe the distribution of those people with advanced degrees, okay? So you're going to tell me the center, any unusual features, the shape, and spread. Now, it's tougher doing it from a box plot for certain pieces of that than it is from a histogram, but we'll practice both of those things. So I want you to try to describe this. Work with someone around you. I don't want to say be wordy, but be specific, okay? For center, if you just say median is this dollar amount, that's not enough, okay? You want to talk about like the median income earned by people with an advanced degree is, okay? Like, again, context of what it is you're talking about. Don't just say center, $60,000 or whatever it is. Does that make sense? Okay, so it's going to take you a little time to do these descriptions. So go ahead, work on that. So just do number 1 to start with, okay? Like all 4 parts of it, but only question 1.
Okay, so first thing I wrote is definitely supplier.
Yeah, of course.
So the center, percent,
Oh,
I can,
we're on this one.
yeah, but
median is about 60.
No, the question's on this one. What?
but like this ring, right? Yeah.
Yeah, yeah.
So the median.
Yeah.
So
That's
then,
like, there's 25% of the values on this one.
I just wanted to let you know, and I'll probably
So
put
there's
like
an
a job
8
first with them.
Okay.
I like got a minor concussion the week before school started, and it's been fine, but today it's been
Bugging
like,
you.
I said like,
yeah, so I just wanted to let you know.
Yeah,
But
so
I'll bring
anytime-
it in or something.
It's fine if you don't
Okay.
I trust you.
Okay, thank you.
But so if you're like, I can't look at this right now, like just, I won't be like, what are you doing back there? Okay, so just thank you for letting me know, but
Yeah.
take like the breaks you need.
Okay,
and
thank
that's
you.
Not a quick process, so hang in there.
Mr. Lee.
Yeah,
So are we talking, so what are the specific values that you want to talk about?
for which one?
Number 1.
So for center, what do you think? Do you want to use mean or median? Yep, median's given to you.
I mean, that's like
The U, the unusual stuff, what you can really see in this is maybe an outlier. You can't see like gaps and things like that because
Yeah.
of the way the box plot is drawn. Shape, there's not really a number for that. That's more based on what you think this looks like, which again,
Yeah.
we didn't do a lot yet with box plots, so that one's kind of tricky. And then range, you could either, or for spread, you could talk range or you could talk IQR, because you can see both of those in the box plot.
Is that going to be, like downward sloping? It's definitely, yeah, it's definitely.
Oh, that's my phone.
what would you say? I think you should probably say like income and eligible.
You look at it like this, and if you look at it unusual features, we said that there was an outlier around
Yeah.
Should we say all of them or like single? Wait, you're doing the one?
I'm on.
I was on spread.
Oh,
Read the following. This one's great.
I wrote the shape.
No, that's fine. No, I mean it doesn't hurt.
You
I just
all
did
that,
it
or?
this one I think
Try to find it because there's no actual.
Yeah.
I'll go shoot it. Well, we can say it's you.
Yeah, it comes out.
Perfect.
You want? Probably.
Yeah.
Going up.
Positive. Or no, it's you negative school. Like, the numbers are super high. Actually, no,
We know they're.
you're right. They're bunches of low. You're right.
Some of them
Yeah. But the,
No,
definitely all this.
We're doing this, point
So it's
to
you. Yeah, sorry, I can do something.
or yeah. So would it be an outlier 155 or I don't know.
I don't think, because I think they're different. I don't think so. It's a positive?
Yeah, I saw.
Yeah. Let's say there's a positive.
So for the outliers, like would you say, would you find one on
I was gonna say that's not like
So exactly how many outliers there are.
I don't know.
Calculate it, go, oh, above this would be an outlier. In that whisker, you don't know, like, yeah, like the maximum probably is there another value right next to it? You know what I mean? Like,
That's a good
so
point.
you say there's at least one outlier, but you can't actually tell how many there are.
What can we add to saying that there's a positive skew? We have to like add something to that.
an outlier?
Just that there's a skew, right, is what you're wanting to say?
Yeah.
Yeah, I would
And
say
since you said it was a
the
positive,
distribution,
I think that's good.
income of people with advanced degrees.
Okay.
Yeah, there's not a lot else you can say. So spread, actually, because you can either use range or IQ. Oh, here we go. So range is just using maximum. We just kind of follow it over and exactly what everyone else has experienced and just show like
Okay, perfect. Thank you.
the other option is IQR, which is the edge of the box. So that's really that edge. Same idea as right.
And then just clarify that you're doing IQR.
Yes.
Okay, awesome.
Yeah.
So it's spread something. Can we choose one?
Yeah.
Can we choose one? That's really good. Great. Because community does a lot of things.
So then I think it's like,
But that's not, wouldn't that not be the best ever to use? Because there's like one outlier. I don't know. We could also use that. I'd rather much better. Yeah, actually, that's the only one.
yeah, and IQ.
Oh, yeah.
Oh, yeah.
Of course.
Actually, IQ I always might be better just because we do have those. And they're like supposed to be. Or you, because like the range should be about here. That's like not even half 25%.
Fill that out.
Like if you did that,
Oh, okay. Okay. I just stood up here. I promise to that.
Downstairs, and we will force it in English, and they stop. They stop. They stop and they stare at their head, and we're like, so
That is part of like the you're saying. Like, saying that. All right, like most people are done, let's go through this one. All right, so describing the distribution. So I would start with center on this one. And guys, even just like label it for me. Be like, okay, I'm doing C.
The way this is at FRQ would be more so, but we're talking about.
Yeah, sure, put a little C next to it. Help the readers out. Encourage them along. Like, hey, I know what I'm talking about here. Yes. So is everybody okay with why we pick median and not mean for this? Yeah, we can't see those individual data values, so we don't actually know what the mean is. But we know the median because that's one of the numbers in our 5-number summary on the box whisker plot. So I would say the median, and I'm definitely not going to have enough room writing on this thing. So the median income earned by people with advanced degrees is about or approximately, I said 65,000. Agree, close, somewhere around there. What'd you guys say? 60? Okay. Yes, correct. All, that's all fine, okay? And that's all you have to say for center. But if all you wrote down was center $65,000, not okay, all right? You need to tell me whether you're talking mean or median, and you need the context of the problem, okay? All right, for you, what do you think, guys? Were there any unusual features? Yeah, it looks like it. When you look at that box and whisker plot, did you guys see how the whisker going up is really long? That indicates that there's probably an outlier up there, okay? So I would say there appears to be at least one outlier on the right. And I'm trying to squeeze this in here, so if you can't read what I'm writing, please let me know. You need me to repeat any of that. So that'll come when we talk shape. Yep. And then again, when we do shape, I'll do that one next. Again, go back to context. Don't just say, it's skewed right. Like, yes, and you and I both know what you're talking about, but you won't get full credit for that. Okay, so the distribution of income earned by people with advanced degrees that's those degrees is skewed right. Okay, and even though it's a vertical box and whisker plot, everybody's okay with skewed right? Get that okay. All right. Then spread. You've got two choices here. You could do the range or you could do the IQR. And you can find both of those on the box and whisker plot. Range is just maximum minus minimum. IQR is the top edge of the box minus the bottom edge of the box. And you're just approximating here. Like, it's not easy to read the exact numbers as you follow it over on your little chart there. So do the best you can. I'll do both of them. The range of incomes earned by people with advanced degrees I'm going to say is about 300,000. You could even list how you found it if you wanted to, or you can just say what the range is. If you want, you can also include the IQR, maybe say with an IQR of about 60,000. And again, if your numbers are slightly different than that, that's okay. Like, it's not the most exact round. Yeah, so let me go back to where this was given. Maybe. There we go. So IQR is just Q3 minus Q1, which on the box and whisker plot, it's just the edge of your boxes. So like that's Q3, that is Q1. Okay. Does that make sense? Okay. Okay. Questions on that? Do you guys see what I mean? How it's like, it's not actually that hard. You just have to write and explain exactly what you're doing and what you're thinking. Okay. All right. We're actually going to skip number 2 because it's pretty tedious to put that data in. So we're not going to do that. Let's try number 3. So first thing we're going to do here. We're not time. What do we have? 10 minutes left. All right, draw parallel box plots of these two distributions, label them, and provide a scale. So you can do that when you're drawing essentially your x-axis. So what numbers do I need to make a box plot? What'd you say? I'm sorry. The median, good. What else? There's 5 things I need. Max and min, good.
Q1 and Q3.
Good. Do you guys see in this little table? Minimum, Q1, median, Q3, maximum. That is a computer printout of this dot plot of information for you, all about body temperatures of males and females. So you're going to take that dot plot and using those 5 numbers, turn this into a box plot. So let me just give you a little bit of guidance. Like, if you're doing a parallel box plot, that means you're going to have one going sideways for females and then one going sideways for male with, if I can draw, the scale along the bottom. So these temperatures you're going to want to do like B6, 1, 2, 3, 4, 5, 2, 3, 4, 5, maybe 7. Does that make sense? Like all the way out to 100. Try to be consistent with your spacing. I am clearly not doing a great job of that. All right, so I'll give you a minute here. Try to make your box plots, and then we'll go over them. Title it, so I'll put that over on the side, body temps. Females and males. So talk to each other. Let me know if you're stuck.
And I never realized until I finished this whole thing.
Yeah,
And I have like, oh, I quit. I find that.
Or like, you're just like,
Yeah.
okay, guys, I'll draw these up here so we can. So guys, I always like to just put the 5 dots on there and then try to connect them. All right, guys, we've got about 4 minutes left here. We're going to go ahead and stop there. We will do the comparison next time between these two groups, but I'll leave that up there. Make sure you guys have the box plots right, okay? Your data journals are not due for a while. I'm going to pass them out just so you have them if you want to get started on them. If you want to put them there. Yeah, I think so. And it's kind of annoying that it's kind of just like, not that, because sometimes people like I also put it with the for you guys, so I can give you some class time to work on it. A little bit of practice is all have time to work on it. Next week. I'm not going to make you say this this morning. Okay. Okay, thank you. Yeah.